Welcome to helpyourmath.com. In today's video, we're going to be covering the product rule of exponents. And the product rule of exponents occurs when you're multiplying two bases that are the same with different exponents. And what happens when you're multiplying these different bases with these two same bases with different exponents is you have to sum the exponents up. From there, whatever the remainder of the exponent is based on if it's a negative exponent or zero exponent, you have to follow the previous rules of the negative exponent and the zero exponent, which you can find in our videos. We have two videos that cover both of those areas. So let's begin with the first problem here in the set of our 5. And in our first problem here we have x to the third power times x to the fourth power. Now usually in a long breakdown, the reason for why it works this way is we can expand these 3 times and expand these 4 times. And what happens is they're all the same base, so we get the 3 plus the 4 x's multiplying, which becomes x multiplying 7 times. And for that reason, we just add the exponents up. So we take the 3 and the 4 and we add them as powers, and we get x to the 7th power. In this case, we don't have to worry about any extra steps because the sum of the exponents are not negative and they're not 0, so there's nothing else to do. And we're done with this problem. Let's move on to number 2 now, when we're adding a positive with a negative exponent. The first problem is the result of adding 2 positive exponents. In the next 2 problems, we're going to have a sum of a negative and a positive. And the outcomes should be different. So let's take a good look at this. We have x to the 2nd power times x to the negative 5th power. And when multiplying these kind of exponents, again, we're going to add them. But because we have a negative exponent, remember to substitute your value in sum with the parenthesis set, all right? So we're going to have x to the 2nd plus negative 5. And 2 plus negative 5 is going to give us, since the signs are different, when we're adding, we're taking the difference of the 2 numbers. 5 take away 2 is 3, and we keep the sign of the larger number. So this is going to give us x to the negative 3rd power. And then when we resolve this using the negative exponent rule from the previous video, if you're looking at our list and set, this goes to the denominator when we reciprocate it, and it becomes x to the 3rd power in the denominator. Moving on to the third problem now. Let's take a look when the first number is negative and the second number is positive for the exponents. And in this case, we have x to the negative 2nd power times x to the 6th power. And here again, we're going to add them. And remember, we're going to put parentheses around the negative exponent. So we have x to the negative 2nd plus a positive 6. And negative 2 and 6 have different signs. So again, we take the difference of the 2 numbers. 6 take away 2 is 4. And we keep the sign of the larger. So it stays positive 4. And that takes care of all of the operations in that problem. Let's move on to a double negative exponent term, right? So we have x to the negative 4th times x to the negative 7th. And what we're going to do here is, again, we're going to add the 2 terms, even if they're negative. So we can add them in any situation. And in this case, we're using parentheses for both of the numbers. So there's negative 4 plus negative 7. And here we get x to the negative 11th. And again, using the negative exponent rule, we're going to move this to the denominator. This reciprocates and becomes 1 over x to the negative 11th. Now these can also occur in fractions. So if we had something like 1 over x to the 3rd times x to the 4th, this will also be just 1 over x to the 7th. And in the case our denominator were a negative number, like 1 over x to the 2nd times x to the negative 5th, we get 1 over x to the negative 3rd. And this goes back up to the numerator, right? So just remember your rules for negative exponents, and we can take care of these properties whether they're whole numbers or whole terms like numerators or denominators. They work identical. Now let's take a look at the final case here when we have 2 powers that are opposite powers. This is a pretty important rule because this takes precedence with the power rule of 0, right? The 0 exponent, not the power rule of 0. But here when we have x to the 8th, and we're multiplying by x to the negative 8th, the sum of the terms are going to be x to the 8th plus negative 8. And this has a sum of 0. And anything to the power of 0, like you can see in our 0 exponent video, will give you a 1. And that's your final answer. Thank you.